Okay, class, now that we've all made our predictions, let's go on with the demonstration. So what I'm going to do is first take my finger and put it on the aluminum. And we're going to just wait about 30 seconds or so, and then we'll take the reading of the probe. Now, why I like using the temperature probe is because it can give us real-time data. It's nice to look at it in the books and see, you know, metals and non-metals and how they react, and I can tell you how they react, but it's nice to see firsthand how it actually does work, because it can help you retain the information a little bit better. Okay, so that's about good. So now what I'm going to do is place my finger on here, and then I'm going to come to the collect, and I'm just going to collect our data. And it's going to collect, and it's going to take about 30 seconds to do 30 consecutive runs, and then it'll give us a reading. And then when it's all done, I'll have you come up here and so we can all see and discuss what the results are. Okay? I'm just going to stop it. Okay. Alright. The next one we'll do is the foam. So I'll just take another finger and put it on here first. Wait about another 30 seconds or so, and then we can read the temperature of my finger from the foam. Does anybody have any questions so far about what I'm trying to do here? Or any input? I don't want answers as to what it's going to be, but I would just like maybe for you to think about other ideas or other ways that our skin uses temperature. When we touch a hot stove, you know, our skin is like a temperature probe. Our fingers are like temperature probes. We know when something's hot, when something's cold. Okay. So I'll just keep all that in mind, that this is also real-time things that we use in everyday life that we sometimes take for granted. Okay. So here's just taking more collecting data. And it just makes it makes a graph, and it makes a table, and then it makes a graph. Okay, so now we can stop it. Okay, and we can go to the last one, which is the wood. And right after this, we can come up and see which one was the best conductor of heat of my finger. Okay. All right. Now, let me just fit this to scale. Okay. Okay, class. Now, as you can see from our graph, the red line is the aluminum, the blue line is the foam, and the green line is the wood. So based on this, you can see that the heat from my finger conducted it through the most was the aluminum. It brought it at a lower temperature because it was able to take the heat from my finger and generate a flow of thermal heat through the aluminum, because aluminum is a metal. The other two are not metals. So here's a perfect example, as when I say metals conduct better than non-metals, it's because we can see here that it conducts it better because my finger temperature is lower here. If it didn't conduct it better, my finger temperature would stay at a constant rate, which is pretty much where these two are. They're up here, and you can see way down the aluminum. So once the thermal heat transferred from my finger to the aluminum, it made it cold, and that's how you can see. This is why it's so cold over here. So anybody who picked the aluminum was correct because it was a metal. Now, when they ask this to you on the Regents, you'll be able to answer that that they have, that when they ask you, okay, based on these four, which one would be the best conductor of heat, you're going to go for the one that's the most metal. The one that's and you don't worry about these two. That's why I didn't ask you to put them in order of 1, 2, 3. Because it doesn't matter. You only need to pick one. Okay?